Welcome back everyone to another episode of the Doom series, and in this video we are going to learn how to construct wall texture from the wall patches that we loaded earlier. So first let's look at the format of our wall texture. So if I open up the new header file that I've created here, walltexture.h, you can see that this is very similar. In fact, it's almost exactly the same as the patched one. So basically we've got a width and a height and an array of unsigned integers, which is representing the actual data of the wall texture. So this represents a single wall texture, and for loading this we'll have the appropriate functions in our WOD file. So if I open up WOD.h, we are going to go here, and here you can see we've got a new function which returns an array of wall textures, which is going to be called WOD read textures. And this function, along with the pointer to the number of textures and the WOD pointer, it takes another argument which is the lump name. And the reason we have that is because there may be multiple lumps that may correspond to texture. So there is texture 1 representing the shareware version of the textures, and then there's texture 2. So we allow that to be specified as a parameter. Now for actually reading this data, we are going to go under our WOD.c file, and here you can see that one thing that I'm changing is that in our WOD read patch function, we are going to initially set this to be 247. So the value of the patch is by default gonna be 247. This is because many Doom utilities use the 247 index, which represents black, to mean the transparent pixel, even though this is not technically the correct thing, and it's going to work well enough for Doom 1 map. However, a few Doom 2 textures may not work correctly with this, and we can fix this later, but for now we are going to just set this to 247, and we are going to, this is going to represent, 247 is going to represent a transparent pixel. And now going to our WOD read textures function, you can see inside of this we first of all read the patches, because textures are made of patches, so we first read that. Then we read our lump index for for the actual texture, and then we get our texture lump with that index. Then we set the number to for that we just read the first 32-bit integer. So each texture lump starts with a 32-bit integer, which represents the number of textures in that lump. After that we allocate memory for those textures, so we just use malloc to kind of get that number of textures, and after that we loop over each texture and read it. So for this we first of all calculate the offset of the texture. So we get we skip the first 4 values, which represents the number of textures, so we skip that. Then we use I multiplied by 4, and the reason we multiplied by 4 is because this is like 4-byte integer, so that represents the offset of the texture in this lump. So that means that all of the texture data is situated at this offset inside of the texture lump. So for reading the texture attributes, we first read the width and height as 16-bit integers, and those are represented by offset plus 12 and offset plus 14. So at offset 12 and offset 14, the first bytes are other values which we don't really need right now, so we are going to skip those. So apart from that we just get offset plus 12 and offset plus 14, and we use that to actually read our width and height of the texture. After that we allocate memory for the texture by using malloc, and we just allocate the number of width multiplied by height. And then we use memset, and again we use 247 here because that means the transparent pixel. We set the texture data to that, and now we need to actually read the patches. So at offset 20 in the texture data, and all of the other offsets, by the way, they are not necessary for us, so we're gonna just skip them. At offset 20 in the texture, we have got the number of patches that make up these textures. We read that, and then we loop over each of the patches. Now for each of the patch data, you can see that for the patch data we just take our each patch data is like 10 bytes long, so we multiply j by 10, then we add to that offset of the texture, and then we add this 22, 24 and 26. So at offset 22 we have got the origin x of the patch, so the patch may not be located at the top left of the texture, so this represents at what point the actual patch starts inside of the texture. And then we read origin y, and then at 26 finally we read the actual index of the patch, and all of these are 16-bit integers. So with the index of the patch, now we can use this to actually construct the data. So we first of all get our patch from our patches array, which we loaded earlier here, if you remember. So we got the patches array here. We get our patch by using the patch index into that array, and then we loop over the patches width and height. So we basically loop over each of the pixel, and here we calculate the texture x and y coordinates by adding the origin x and y to the y and x of the patch. So we add the texture's origin to that value. After doing that, we make sure that this texture X and texture Y falls within the texture range, and we make sure that our data byte is not 247 because that means transparent. So if that all is true, then we set our textures data this pixel to this data byte, else we just skip it. And yeah, that's going to essentially load all of our textures. So for using this, our program really hasn't changed that much. So all we do is we, instead of loading the textures, we load instead of loading patches, we now load wall textures by using this function, and we use texture1 as the name of the lump, and then we generate everything pretty much similarly. And here we set everything here just like we did in the last video. The only thing that has changed is that now this is, instead of being patched, this is wall texture, and we are now using the word read textures function. So with that, we can go ahead and run make, and what you should see is that we get all of our textures, and these are the Doom textures. If you were to open it up in an editor like Slate, you'll see that all of these are correct, and you can see we are getting one by one each of those textures right where they are supposed to be. So that means that this is working perfectly. Anyways guys, it's going to be pretty much it for this video. I'll see you in the next one, in which we are going to learn how to actually get these textures to display on our walls instead of in a 2D view. So stay tuned for that. Make sure to like and subscribe as well so you don't miss the next one, and share this video with other people as well, and bye.